Hi, so we are in section 8182 here where we are building confidence intervals. And in some of the problems, we have to look up a critical value. For example, this problem here on the screen is from one of the video lessons. And you have to use this function from the calculator, the inverse t. Okay, so up here on the screen, we did an inverse t of 0.02569, and previously in the video, they came up with a t-score of 1.99. Okay, now, depending on the version of your calculator, let's say that you have an older version of the calculator that does not have the inverse t function on it. I think the majority of you should, but if you just happen to have an older calculator, is there a way to do it without that function? Okay, so what we're going to see here is if we can use a table to come up with this 1.99. Okay, so I have posted on Canvas tables. Let me just scroll to the top here. So this is posted on Canvas. These are, I think it's final tables for Math 1260. So on the first page, you have the sample size formulas and then a Z table. Second page is the rest of the Z table. But then on the third page here, it's the table that says Table 5 Students T Distribution. These are different T critical values that you could potentially use. And we're going to be using this elsewhere in the course, but right now you can look up at the top, it says C. You're going to look up your confidence level here. And then across the side here, you're going to look up your degrees of freedom. So the confidence level will just be given. Now you are limited on this table to just these confidence levels. For degrees of freedom, you're going to take your sample size minus 1. Now if you look here, has all the numbers, but as you go down, once you hit 30, they start to jump. Because your degrees of freedom, as your sample size doesn't change, the critical values just change very, very slightly far out in the decimal places, so it doesn't matter as much. Let me go back to my example here. So in this example, we are looking at a 95% confidence interval, and we are looking at a sample size of 70. So we're going to look on that table, we're going to look up that C level of 95%, and we're looking up a degrees of freedom of 69 because that's n minus 1. So 95% and n minus 1. C, 95%, so we're going to use this column here. And then across the left-hand side, we want to find a 69. The problem is there is no 69. It jumps from 55 to 60 to 90. So if you can't find your actual DF that you're looking for, you're going to find the next smallest whole number. So in other words, kind of round down to the number that's on the screen. So if we're looking for 69 and we can't find it, 60 is the next smallest number below it. So we're going to use 60. We're going to go over. Let me double check the right column here. Yep, this is our 95% column where my arrow is. And we are looking at a T critical value of 2.000. Okay, now that has some rounding differences there. If you go back to that example, the calculator came up with 1.99. That's very, very close. All that is a rounding difference. So if you were doing this problem by using the table instead of the inverse t, you would use a 2.00 here, and your values would be very, very close. Okay. Hope that helps with the table. Again, most of you, this shouldn't be a concern, but in case you don't have that inverse t function, I wanted to give you another option. Good luck.